Now in this class, you've already seen the core things that you need to know about multiplication, division, and remainders. There's multiply, keep the low, multiply, keep the high, and division and remainder. So now it's just variations on a theme, and that theme, for example, 3 multiply div rem is integers. We now have integer a times, divide, and modulus. So what do we usually see when we have 64-bit code that uses 32-bit values? That's right, W suffixed instructions. MULW, DIVUW, and REMUW. So exact same assembly instructions as we saw in our first example, now just W suffixed. So W suffixed is word sized, so we have multiply, treating them as word sized registers, and keep the low word size. So RS1 is our source. This is a 64-bit extension, so this is only in the RV64M extension. So RS1, treat it as a 32-bit value, so take the lower 32 bits, multiply it by the low 32 bits of RS2, take the result of that, which is keep only the low 32 bits of the 64-bit result, and then sign extend it and put it in a 64-bit register. So all the same, you're just operating on word size registers, all the same as a normal mul. So T0 and T1, we've got 2 times all A's, but we're only going to keep the bottom 32 bits. So the bottom 32 bits times 2 is going to overflow the possible 32-bit value, but then it's just truncated. We keep the bottom 32-bit result and then sign extended up to 64 bits. Another example, MULW, we've got 2 times 7 and all zeros, and the net result of that is going to be E and all zeros, and then sign extended up to become a 64-bit value. All right, then the divide unsigned that we saw before, but treat them as word size registers because this is an RV64M instruction. So bottom 32 bits of RS1 divided by bottom 32 bits of RS2. Then you have the result as a 32-bit value that is sign extended. So 5 divided by 4, well, now instead of 5 divided by 6, 5 divided by 4, 4 goes in 1 time. Nothing special about that. Then we've got 5 divided by 6 as before, and that goes in 0 times. Not exactly the most creative example, I know. Remainder, same thing. Remainder unsigned word size registers, so lower 32 modulo lower 32, and it's only going to be a 32-bit result, but just putting it there just in case, and sign extend the result. So B modulus 3 is a remainder of 2. On the other hand, 5 modulus 6 is a remainder of 5, because 6 goes into 5 0 times with a 5 remainder. Okay, so like I said, it's all just permutations from this point in multiplication and division and remainders. So step through the assembly, check your understanding, that you understand that it's using 32-bit register values in 64-bit code.